Welcome to
accelerated motion.
So acceleration is the last topic we're going to be discussing in this motion part. Again, we do graphical analysis, but that should be just review. But acceleration is defined as a change in velocity over a specified time period. It is a vector
rate of change.
Rate of change. There we go. It is a vector quantity, which means it has both magnitude and direction. So don't forget the directions when dealing with this.
Mr. Rayner, is there a scalar version of acceleration?
No.
It's always a vector. There always has to be a direction. And this is the part that students don't like. Formula, pretty self-explanatory.
Yeah, so the formula is pretty self-explanatory. Again, you can rewrite this as V2 velocity, the final velocity minus the initial velocity, all over the, again, T2 minus T1. But in Science 10, most of the time your T1 is at a 0 point, so it's usually just your T2 value that's given in the question.
That being said, the big thing to watch here is the vector components. This guy and this guy. Assign one direction as positive. Some of those things might be positive, some of them might be negative.
And when we take a look at the units on this, we would have meters per second for our velocities divided by seconds, which give us a unit of meters per second squared. Again, we saw this yesterday in terms of kilometers per hour squared. Again, those are both acceleration units with the time being squared on the bottom.
It is important to know here, guys, that there are the seconds and seconds. They don't actually cancel, they compound. They compound because the top one is on the bottom, and then there's another one on the bottom. That's 2 on the bottom.
Acceleration is usually expressed in meters per second squared, like we just talked about. It can be calculated by finding the slope of a velocity time graph, again, like we discussed in the previous unit. Okay, when an object is moving in a straight line, a positive acceleration means that the object is speeding up, and a negative acceleration means that it's slowing down. Now, that's assuming that you're traveling in the positive direction. Okay, so obviously your positive and negative acceleration will depend on the direction you're traveling, which we look at in the next slide.
Yeah, so if you were going in a negative direction, a negative acceleration would cause you to go faster. What do we got here? The other part here, guys, when we talk about it numerically, is that 3 meters per second squared does mean that you're increasing by 3 meters per second every 1 second. So after 1 second, starting at 0, you would go up to 3. The next one you would go up to 6. When completing your calculations, be very, very careful. This is the tricky one.
Okay, again, just one thing to mention here quickly. Again, we do have acceleration due to gravity in some cases. Examples of this would be like an apple, dropping an apple from a certain height. Again, you still feel the acceleration due to gravity, which is 9.81 meters per second squared down. Okay, we usually put this as a value of g, which we start talking about a little bit more later in this unit as well.
Keywords in a question, anything that falls, anything that's dropped, anything that seems like it's just plummeting toward the ground, you have the acceleration. It can be hidden as a keyword. Quick table of what could happen here. So getting back to that whole thing about directions. If you are moving in a positive direction, and we apply a positive acceleration, what happens is that you end up with more positive velocity. You will actually go faster. But if you were going in the positive direction, let's say you were going forward, in this guy, you're going forward, negative would mean that you are accelerating backwards. What does it mean to accelerate backwards? Well, that means that your forward velocity will become less positive. This is essentially like if you were moving forward and somebody started pushing on you, causing you to accelerate backwards, you will slow down first. Now, eventually, you may actually come to a stop and flip direction, but the very first thing we have to know is you get slower. These things, if we look at this negative 1 and 2, they're the exact same thing. When negative matches with negative, you end up going faster. When negative matches to positive, you end up going slower. And this is all based on your initial direction of travel and your initial velocity.
So example number 1. An object traveling 40 meters per second increases its speed to 100 meters per second in 4.0 seconds. What was the acceleration of the object? So what's important in the question? We have 40 meters per second, and we have, which is your V1, or VI, 40 meters per second, and we have our VF, which is 100 meters per second, and we have our time, which is 4 seconds.
Now, for this question, V is supposed to be a vector. So, the question does not explicitly state a direction. At this point, if it doesn't explicitly state directions, we assume that they are the same direction. We will assume that these are positive, and we will proceed as such. So acceleration is equal to v2 minus v1 over t. This is equal to 100 meters per second minus 40 meters per second over top of 4 seconds, which is 15 meters per second squared. We're assuming you can use a calculator and fly through that too.
But again, if you want to stop and double check your answer, again, go through the calculation yourself to make sure you get the same thing we do. Example number 2, a Starfleet shuttlecraft is moving at 1,600 meters per second when it begins to accelerate at negative 12.9 meters per second squared for 30.0 seconds. Determine its final velocity, magnitude, and the direction. Yeah. Whatever. Okay.
Essentially, we're always going to have to put something in a question. Some of the times we'll get nerdy things. Just run with them. It's always just an object. So at this point, we're going to go through the exact same thing again. We're going to try to figure out what are our variables. What do we have? We have 1,600 meters per second. Then we have, it says it begins to accelerate, so that's really easy. That's the acceleration. And it says now that it is negative 12.9 meters per second squared. A great question probably would have said positive 1,600, but at this point, if we see the negative and the other one doesn't have a negative, let's assume that that was positive. And then we have a time of 30 seconds. Determine the final velocity.
So again, guys, what you can think of this, we have motion going in the positive direction, okay, and we have the acceleration operating against it. So what we should see here is that the shuttle should slow down. So we should see as a V2, we should be less than 1,600 meters per second.
And if you get bigger, then you done goofed. So, starting with the formula, A equals V2 minus V1. Oh, that's a 1. Over T. What are we trying to find? We are trying to find V2. Magical rearrangement says V1 plus AT is equal to V2. So at this point, we'll just sub in our numbers. Positive 1,600 meters per second plus negative 12.9 meters per second squared multiplied by 30 seconds. Now this is where the seconds will cancel one of those seconds. So what we see for units is meters per second and meters per second. That's good. That's like saying we have apples plus apples. Now, this comes out to be 1213 meters per second. And the calculator didn't show a positive, but we know that it's positive. So at this point, with our 1213, we can see, compared to the initial, we have slowed down. Logically, this number makes sense.
So guys, keep in mind, what we end up seeing here with these significant digits still matter here. Okay, we would have 3 significant digits here, which would give us 1 decimal place for that multiplication, or... So this multiplication is going to give you a number of 300 and some, so it's still the nearest whole number. So when we're adding, we go to they both have 0 decimal places. So this would be your final answer. And there goes McLeod dropping something again to complete the video.
But we're not done yet. An object is traveling at 60 meters per second east. It accelerates west. If the final speed becomes 100 meters per second, how long was the object being accelerated on? Ladies and gentlemen, we'll fly through this one really quick. We have our VI is equal to 60 meters per second. I see that as east. I automatically make that positive. The acceleration is a negative 5.0 meters per second squared. The final speed becomes 100 meters per second. Now, the fun with this one is we have to start to figure out what direction that 100 meters per second might be in. So if we look at this, you're starting in a positive, and you're applying a negative acceleration. This means you're going to slow down. Then eventually you're going to stop. Then you're going to keep accelerating in the west direction. So this is actually like a level 3 problem in terms of knowing that the only time the speed is going to get to 100 is when it's actually going the other direction. Now, guys, this might sound like it's a crazy problem. This is essentially like you go up on the roof of the building, You throw something in the positive direction up, gravity pulls down, eventually the thing is moving very quickly down. Put the signs in, don't worry, you'll be fine. Time was our unknown. A is equal to V2 minus V1 over T. T is equal to V2 minus V1 over A. T is equal to, subbing in our values, negative 100 meters per second minus a positive 60 meters per second gives us 160 divided by 5 is 32.
Negative 32.
Oh, I forgot to put in 5. 5.0 meters per second squared. And for some reason the pen just switched to red. Now, ladies and gentlemen, the other thing that's worth noting here, and I will switch to red for this, you had a negative here, this became a minus, so the whole top is negative. The bottom is negative. A negative and a negative cancel out. Time always has to be positive. Always. 32 point. Oh, just 32. Because we're doing a division by 2 decimal places, so it's going to be 32 seconds.
Again, guys, keep in mind how you do your notations. McLeod and I have been switching back and forth. Sometimes we use VF and VI. Sometimes we use V2, V1. Whatever you're more comfortable with, we don't care as long as they're done properly.
As long as you don't start putting a final in for an initial, really.
Yeah, pretty much.
That's it.
And that's it. There's acceleration.
In
You're welcome.
11 minutes and 44 seconds. 46.